Okay, so yeah, that day yesterday where I said I was just gonna get through these chapter 3 exercises really quick, and I only got through like less than half of them. Yeah, that happened. So today we'll keep working on these exercises as much as I want to. We'll see what happens. I already decided I'm not gonna do the date before thing. I'm not gonna deal with dates. It's not gonna help me at all. A socialist, right? I don't care about A lists. The cards thing seems possibly interesting. It's really just making sure that I like solidly know how to define all these types, right? Define a variant type suit that represents the four suits. Okay, so let's start on this one. Okay, so let's just say, oh my god, there we go. Cards, right? Nice, love that for me. So this is going to be suit, and suit equals hearts, spades, clubs. What's the other one? Diamonds? Diamonds. Okay. Define a type rank that represents the possible, let's see, where is this going? Define a type rank that represents the possible ranks of a card. 2, 3, 10, Jack, Queen, Queen are A's. There are many possible solutions. You're free to choose whatever works for you. One is to make rank be a synonym of int. Another is to use variance. Yeah, I would hate to use a type alias in this situation. That would be like really, really gross. Are there actual network issues, or is that just my computer? Are we dead? Did we die? We might have died. Did my internet die? Piece of shit. Piece of shit. Are we back? Okay, I think we're back. We're so back. I think we are. Let me see. We're back. Okay. Random network hiccup. Okay, let's see. My CEO got back to me. What did he say? I was load testing some code against RDS, and that's what's happening. The field equals field plus one SQL operation seems to stress out my squeal. That's your first problem using my squeal. Am I right? Am I right? Okay. Surprising. That's surprising. Literally, this is all I'm going to say, and he probably won't say anything else. All right. And if you're watching on YouTube and you have no idea what I'm talking about, well, that was before I started the recording. Anyway, we're doing this exercise cards before the stream died for a few minutes. Hopefully it's back. WTF. Oh yeah, I'm live. Let's see. Yeah, I think we're good. Okay. Stupid internet. Yeah, anyway, for the rank type, I would hate to do this as a type alias of int. I'd also hate to write it all out, but that's probably what I'm going to end up doing. Wow. Missed 8. Let's go. Still missed 8. Here we go. And we're just going to say JQ Okay. We don't have to do jokers, right? Oh yeah, ace. Forgot about ace. Oh yeah, there's no 1. That's ace. I knew that, of course. Oh, that's right. You can't have integer as type constructors in OCaml. So you would literally have to write out the That's really gross. That's really annoying. Okay, I kind of hate that. So what? We'd have to do 2, 3, 4, 5, 6, 7. Pretty much, Nunez. 8, 9, 10. Now it looks a little bit funny that those are just JQKA, but I'm just going to leave it. Okay, we did that. Define a type card that represents the suit and rank of a single card. Make it a record with 2 fields. Type card equals record suit rank. I think this is like correct, but we need a comma probably. No, is it not a comma? Am I forgetting how record types work? Probably. Let's look at it. Records. Semicolon. Classic OCaml semicolon. Ooh, pretzels and hummus, pretzels and fig marmalade. That sounds really good. That sounds very good. Okay. Record type. Let's go. I guess we can put the trailing semicolon there. I don't think we have to, though. It's whatever. Okay. Ooh, look at learn X and Y minutes, OCaml having this on a new line. Bad choice. Bad choice. Okay. I like almost any type of marmalade. I'm a fan. My favorite, I rarely see, but it's like that Saint Dalfour brand, you know, like the French jam, the tall skinny jars, and they had a kumquat. Yeah, you're gonna like that name, aren't you, Nightshade? A kumquat, if you know what that is, tiny little citrus. Kumquat marmalade. So good. So good. I haven't seen it for a while though. Define a type. We did that. We did card, and then define a few values of type card. Ace of clubs, queen of hearts, 2 of diamonds, 7 of spades. Hey Ninja, what's up? Sure. So sure, we could say ace clubs equals suit clubs rank A. Except I don't need that. Does this not work? Am I like completely wrong? Is this not it? It looks correct to me. Why do you hate me? Is it because let's put this on UTOP and see what the actual problem is. It's all good, man. I wasn't trying to be condescending. I wasn't trying to be. Okay. Suit clubs rank A. Is there something wrong with this? Syntax error. Let's see. Equals. Still syntax error. Still syntax error. Is it? I swear it's semicolon. What did I do wrong? I'm just naturally condescending. Yeah. That could be a good way of putting it. Yes. Okay. Am I insane right now? We defined clubs as part of suit. Okay. Clubs. Yeah. This is fine. Is it because can I not use suit that way? It's possible. I wonder if that's the problem. I don't think it's a problem. Crank. Nothing like a crank. All right. Crank. Suit. Nope. That isn't the issue. That makes me feel better. Looks like it messed up that link, but the query probably doesn't matter. It's the worst thing. I'm glad I didn't open it up on the other thing. I just hate it for some reason. I hate that meme template. It is the worst meme template. It's a great thread with pick. For some reason, it's not showing pick's comment. Oh, I see. I see. Dude, is my internet just being stupid again? No, that's an instant pick classic. Yeah, okay. I see it. Terrible. Absolutely terrible. Oh, man. So funny. Okay. So why am I so wrong? Oh, I forgot. I forgot something. So here's records, right? Wait, did I say type? No, I said let ace clubs. I thought this wasn't the way that you do it. I thought you do like an equals. Yeah, but this is in learn X and Y minutes. WTF. It is equals, isn't it? Let's see. Oh, I copied that, but I forgot to actually put it in. Okay, let's update that. Suit equals clubs, rank equals A. Yeah. Dude, learn X and Y minutes is like actually wrong? Is this like an update? Like what the hell? So dumb. All right. Okay. That would do it. Okay. That's funny. It's funny that I forgotten that. I'm not going to bother defining any more values of type card. I think we get the point. Exercise matching for each pattern in the list below. Give a value. Oh yeah, thanks, Amit. I didn't even notice that was you. I thought it was Nightshade just because of the green. Slight variation in the color of green. Yeah. Give a value of type int option list that does not match the pattern and is not the empty list, or explain why that's impossible. Oh, that's actually kind of interesting, I guess. We'll just copy all of this here for now. Give a value of type int option list that does not match the pattern and is not the empty list. Okay, so sum x tail. Okay. I mean, it could be a lot of things. Let's see. tail could match empty list in this case. Sum x. I don't think there is anything besides an empty list. Oh yeah, none. I'm dumb. None. There you go. That doesn't match. How about this one? Sum 3110, none. Obviously an empty list wouldn't match. This isn't very hard. I guess this is why it's a 1 star. I mean, literally anything wouldn't match this. This is not a very hard thing. No. You can't remember rules for card games. It's funny. Sum x and ignore the next argument. Is there anything that... Yeah, the same thing, right? None. Also would not be matched there. H1, H2, tail. That one's easy. If it's just a list with one element, it doesn't even matter what it is. I mean, literally, this would also not match with none. So none is a good answer for all of these. Apparently, it just keeps going. And then head, tail. Let's see. If it's not an empty list, since that's not a valid answer, then this actually would match any list that has a single element. Okay, we did it. We did it, guys. Impossible matches all lists with all non-empty lists. Non-empty lists. Okay, we did it. We're so good at this. Dang it. I just realized no, never mind. I never learned that one. I was thinking I forgot a vim command, but I actually never learned that one. So we're just going Emacs. Okay. We're great. Exercise quadrant. Complete the quadrant function below, which should return the quadrant of the given xy. You could replace it with and it'll match everything. You're right. That's not the exercise I mean. You could also implement a linked list right now, but that's not what we were being told to do. We always just follow the rules here. I am a ardent rule follower. All right. Exercise quadrant. Complete the quadrant function below, which should return the quadrant of the given xy point according to the diagram on the right. Look at this diagram on the right. It looks great. Borrowed from Wikipedia. All right, let's just try opening it by itself, I guess. Okay, this looks too annoying to me. Points that lie on an axis do not belong to any quadrant. I don't think I want to do that. Quadrant run. Rewrite the quadrant function to use the when syntax. I don't care about that. We already did plenty of matches and matches with whens. Depth. Write a function depth tree int that returns the number of nodes in any longest path from the root to a leaf. For example, I do that one a lot actually. The depth of an empty tree, simply leaf, is 0, and the depth of tree t above is 3. Hint, there is a library function. Where did they didn't even define, when did they define a, he's not even defined, where are these examples that they've defined for t's? Like, what the hell is he even talking about? Is he talking about in the book? Like in the chapter where he talks about trees? Maybe that's what he's talking about. I don't think I wrote that in here or anything. Pretty sure I didn't. Nope, sure didn't. Okay. I mean, it sounds a little interesting, but I don't. Should I go back and just look at it and we write the depth function? Sure, why not? Sure. Since it's about a tree, I love me some trees. We'll just do it. So let's just copy this. Node of alpha. Okay, so just a tuple of value left and right. All good. Uh-huh. Okay, so we'll just copy his tree example so we can also use that to test our function. All right, so back to our exercise. Write a function depth that takes a tree, returns an int that returns the number of nodes in any longest path from the root to a leaf. For example, the depth of an empty tree, simply leaf, is 0, and the depth of tree T above is 3. Hint, there's a library function max that returns the maximum of any two values of the same type. Yeah. I don't need anything harder. I mean, who do you think you're talking to? Great tree. Let's see if I like this tree. Autumn Blaze Maple. Not bad. Not bad. Looks like a pretty good tree. You're a maple tree fan? Is that what I'm hearing? Okay. So this shouldn't be all that difficult. Let's say let depth equals we'll say T equals classic Emacs. Emacs died in that frame. Let's get a new frame. Arg's out of bounds. Okay. No, that's beautiful. I like maples. I like maples a lot. Yeah, they're nice trees. Aspens also really nice in the fall. You know, I like pretty much every tree. I like the nature. Okay, so basically the point is we have to go down right and left and see what the max is and kind of like recursively add that, right? Yeah, I've never had an aspen in my yard. I've only had aspens in forests that I've visited, right? Yeah. Yeah, it's interesting. I didn't know that. Okay, so go down each branch and add max, or no, add and take max at each level. Okay. Something like that. So what we probably want is a second function that does some of this. Let me think. Do we really need that? I don't know if we do. I guess we'll start with it not being that. So we can start with our base case. Might help if I actually put the garden where a leaf is 0. And then we have the case where we just have a node and we just have leaves after that node. I don't actually care what the value is in the node. So this is leaf leaf. In which case this is just 1. And then we have the case where we actually have oh, right. I guess we have the 2 other cases, right? We have the case where we have a leaf. Let me just think about this a second. I can get there. Just bear with me. Almost there. Right. So this is just a node, and I don't actually. I guess this is the part I'm getting confused on. Okay, so if that checks if it's a leaf. Oh, yeah. That should do it. So this should just be called L, first of all. Make it a little easier on ourselves. This would just be 1 plus. Depth is the longest distance from the root or distance between selected node and root. I'm pretty sure it is typically depth would include your root. And if you had like 1, 2, 3, it would be a depth of 3. Like, I'm pretty sure the tree above he was talking about is this one, in fact. And this would have a depth of 3. Basically means it has 3 levels. Yeah. Okay, right. So since we already matched on whether this had a leaf. Yeah, but longest distance from the root, it kind of feels like you're saying it would be 2 in that case, right? It almost sounds like you'd be 1, 2. But saying it's 3 deep, I don't know. It's a little different, but that could just be my interpretation of the English, which we all know I'm a little sus when it comes to English. Okay, so this example would not be tail recursive, but I don't really care right now. So then we would say 1 plus depth L. And that should work. Okay. And then if we have a node that has a leaf here and not a leaf here, we'd still say 1 plus depth R. So we could make this like a little bit better and say node leaf B for branch. Wrong one. We'll call this B. And then we have 1 less case. And then we can just do our final, which would be node LR. And it would be 1 plus what is it? Int.max. Why? That's hilarious. Look at what the type inference now is, because I aliased int with poke AHP. Int.max actually takes a poke AHP, 2 poke AHPs, and returns a poke AHP. Max distance root leaf is the longest distance I'm talking about. Oh, okay, sure. Yeah, that makes sense. Int.max, and then we would say depth L and depth R. Messed up the parens. Okay. I didn't define this as recursive. Thinking that you're just gonna need some of this, but maybe not. Expression has type Ch3 to poke HP, but an expression was expected of type poke HP. Okay. That's surprising. Why did that happen? So why is this returning? Basically, this should be an int, but it's not returning the other thing. Why do you feel like configuring BSPWM right now? I don't know, man. I don't know. When I was on Linux, I pretty much just I changed my window manager one time and then I was just fine. But I'd probably do something different. I would probably go with a tiling window manager or something today. Okay, so for some reason, depth L is returning a function of this instead of returning an integer. A function of tree to integer instead of returning an integer. What did I do wrong? Obviously, the leaf looks fine. Is it something about this? I don't think so. Not actually sure. Let's just try adding some parens and seeing if it gets us out of any of this. Doesn't seem like parens are an issue. So why do you think depth B returns a function? Node underscore leaf R. It's there. It's on the same line. I have if left is a node and right is a leaf, and I have as left is a leaf and right is a node. I mean, maybe it hates this for some reason. I don't know why it would. Yeah, well, it's easy to miss if you're looking at it. Like, it's easy to miss the ors sometimes. We'll just go with this for a second. Nope, same problem. This expression has type tree. So depth is being inferred as taking a tree and returning a tree to int. God, the poke HP alias is killing me right now. Okay. So why is that being inferred as that? It could be here, I guess. This last one. No. Also seems fine. Huh. Oh my god, it's because of how I did the function. I put T there, but I wasn't supposed to. It's a single argument function. When you use the function keyword, you don't put any arguments on the left-hand side. Simple stuff. It always is. It always is simple stuff. Okay, let's get rid of unneeded parens, which I believe will be this one as well. But I'll keep the depth L, depth R. Those are probably important. Okay, that was it. This should work. Again, it's not tail recursive, but yeah. That's what I meant to say. Oh yeah. I have to take all of this. Y28J. Get rid of unnecessary parens, yeah. Hey, I only put parens when they're necessary, okay? So depth T should be 3, depth leave should be 0, depth. That's good enough for me. Hey, that wasn't too bad. That was fun. It's always fun to think about a tree depth function. I like that sort of thing. Exercise shape, write a function, same shape, tree bool. Ooh, shape function that determines whether two trees have the same shape regardless of whether the values they carry at each node are the same. Okay. Don't tell me what to do. Okay. So I'll probably just pass the same exact tree in twice, and that should be fine. Let rec same shape. So this is going to be T1, T2 equals match T1, T2 with... Okay, so the first example, similar to the other one, is if they're both leaves, we know that this is true. And if... Oh, I see how I could have gotten rid of an extra branch. So even on the depth function, I see why he had said 3 branches. Even on the depth function, this one's actually not necessary. Because I don't actually have to check for this. It was kind of just like a little thing, right? This is checked before. So let's get rid of that. Make sure it still works the way that we expect. Depth T, depth leaf. Yeah, same thing. All good. So we don't need the extra leaf check that way. So here, what we would do is just say node. Don't care about the value. Node LR. Yeah, that's right. So then we would just say same shape L1, L2, and same shape R1, R2. Should be right. And then we just have our final condition, which is basically if neither of those are true, it's just false, right? I think that's true. I think that's true. Otherwise, false. I think this will work. So if we say same shape T, we get true. That's nice. If we get, say, same shape T leaf, we get false. That's also nice. Is there anything special? I guess let's just do one more. What if I did a node node constructor with, I don't know, 25 leaf. Just making sure that we're doing the right thing. This should be right. Yep, false. Okay. Same shape. Leaf. That didn't return true. We'd be in a world of hurt. Not bad. Four lines of code, whatever that is, 5 lines of code for a little same shape function. Yay, pattern matching. List max. Okay, write a function list max that returns the maximum integer in a list or raises failure list max if the list is empty. I don't think I care about that too much. I guess because it has an exception. Okay, I guess I don't know how to work with exceptions, but like I also don't want to use exceptions. I just want to use results or options anyway. So I'm not going to do that. I don't care about exceptions. Is BST. Okay. Write a function is BST. Takes a tree of tuple of alpha beta that returns true if and only if the given tree satisfies the binary search tree invariant. An efficient version of this function that visits each node at most once is somewhat tricky to write. Yeah, it's not the easiest thing. Write a recursive helper function that takes a tree. We could do it, but it is like a lot of work. It is really funny that this is a 4-star and like the other 4-star was literally just making a recursive function tail recursive, and that was super easy. I think we're going to skip this one just for the sake of time and the thought of us actually speedrunning this book, but I could write it okay. I could. Exercise quadrant poly, modify your definition of quadrant to use polymorphic variants. I didn't do the quadrant and I worked enough with polymorphic variants that I don't really care. Okay, higher order programming. Functions are values. Okay, here we go. Chapter 4, higher order programming. We finished chapter 3 exercises. How about it? Let's go, as the kids say. All right, let's get some water. Time to drink, everybody. Everybody needs to hydrate. Functions are values just like any other value in OCaml. What does that mean exactly? I don't know. Just kidding. This means that we can pass functions around as arguments to other functions, that we can store functions in data structures, that we can return functions as a result from other functions, and so forth. Yeah, I already know what higher order means, so this whole chapter is probably not going to be that interesting to me. But we'll see. Consider these functions double and square on integers. Let's use these functions to write other functions that quadruple and raise a number to the 4th power. Yes, we can just compose double and double. If OCaml had an effing compose operator, that would look really nice, like in Haskell. We'd just do double dot double and we'd be done. Let quad equals double dot double. Why don't you like that? Why don't you have that? All right. There is an obvious similarity between these two functions. What they do is apply a given function twice to a value. We already know this. The function twice is higher order. Yes, its input f is a function, right? Higher order function is a function that takes a function as an argument, in case you didn't know. The abstraction principle. Above, we have exploited the structural similarity between quad and 4th to save work. Admittedly, in this toy example, it might not seem like much work, but imagine that twice were actually some much more complicated function. Then if someone comes up with a more efficient version of it, every function written in terms of it, like quad and 4th, could benefit from that improvement in efficiency without needing to be recoded. Part of being an excellent programmer is recognizing such similarities and abstracting them by creating functions or other units of code that implement them. Okay, sure. Oh, yeah. No, that's a good idea, Meat. You could do that. I mean, it wouldn't even be that inefficient in the sense, I mean, it's inefficient in that you're not doing like an early break, right? But it wouldn't be that inefficient in the sense that like you could make I mean, it's just computers are decently good at that sort of thing. It depends on the size of the tree, right? Um, Part of being an excellent programmer, yeah, okay. So abstraction principle, yes. Yeah, memory usage for extra array storage, sure. We're programmers. We don't think about memory, obviously. Just kidding. Let apply f of x, yes. Pipeline operator is a higher order function. Yep. Very cool. Let pipeline xf equals fx. Uh-huh. Yeah. Like just a thought though, like if you're not used to languages that let you define operators and stuff, or even do other meta programming things like macros, which other languages do. But even without macros, like being able to define your own operator is so freaking cool in a language, right? I mean, the fact that you can actually just create a pipe operator and it's just so stupid simple. It's so great. I'm a fan. I don't actually know of other languages that let you do that besides like outside of macros, like just a normal declaration for defining an operator besides OCaml and Haskell. Swift lets you do that as well. Okay, I didn't know that. That's cool. +1 for Swift then, I guess. We can write a function that composes two other functions. Yeah. Mm-hmm. Mm-hmm. We know what compose is. Meaning of higher order. Okay, this might be interesting because this is more like CS stuff that I wouldn't know. The phrase higher order is used throughout logic and computer science, though not necessarily with a precise or consistent meaning in all cases. In logic, first order quantification refers primarily to the universal and existential quantifiers. These let you quantify over some domain of interest, such as the natural numbers. But for any given quantification, say, I don't know how to say that. How do you pronounce the A that's upside down? I don't know what that is. I didn't take math in college, really. I took statistics, and that's it. The variable being quantified represents an individual element of that domain, say the natural number 42. Second order quantification lets you do something strictly more powerful, which is to quantify over properties of the domain. For all in there exists. Oh, got it. Right. Universal quantifier for all existential there exists. Cool. Thanks, Amit. I should have probably figured that out from when I was doing all the theorem provers, but I don't think I did. Second order quantification lets you do something strictly more powerful, which is to quantify over properties of the domain. Properties are assertions about individual elements. For example, that a natural number is even or that it is prime. In some logics, we can equate properties with sets of individual. What does that mean? In some logics, we can equate properties with sets of individual. For example, the set of all even naturals. Okay. Sure. Maybe he meant individuals, probably. So second order quantification is often thought of as quantification over sets. Okay. So first order quantification, universal and existentials. Second order quantification is quantification over sets. You can also think of properties as being functions that take in an element and return a Boolean indicating whether the element satisfies the property. This is called the characteristic function of the property. Okay. Third order logic would allow quantification over properties of properties, and fourth order over properties of properties of properties, and so forth. Higher order logic refers to all these logics that are more powerful than first order logic. Though one interesting result in this area is that all higher order logics can be expressed in second order logic. Okay. In programming languages, first order functions similarly refer to functions that operate on individual data elements, whereas higher order functions can operate on functions, much like higher order logics can quantify over properties, which are like functions. I don't know if I learned anything from reading that. I mean, I guess it tells me a little bit where they get like the higher order name from, but I don't know if it actually added value to my life. Not sure. Famous higher order functions. In the next few sections, we'll dive into 3 of the most famous higher order functions: map, filter, and fold. Okay. I think most of us know what map, filter, and fold is for the most part. I think fold is probably the thing that trips people up a lot more than map and filter. I think map and filter is really easy to understand. It's just a one-to-one transformation. I have type A and I return type B, which could also be the same type as type A, right? But we map over a collection or a list or a value of some sort and apply ideally a pure transformation. So that's map. I'm not going to read map. I am interested at how they deal with side effects in the standard lib version of map. Sure. Okay, so when evaluation order matters, we need to use let to ensure it. And it only matters if there are side effects. Okay. So you can have a side effect in a map. It is what it is, I guess. Map and tail recursion. Okay. This might be interesting to read. Astute readers will have noticed that the implementation of map is not tail recursive. That is to some extent unavoidable. Here's a tempting but awful way to create a tail recursive version of it. We have a recursive function, map tur-ox, f-ac, ht map tur-ox f, acat, fh, t let map tur f, map tur-ox f, let list equals map tur funx 1 2 3. Sure. To some extent that works. The output is correct and map tur-ox is tail recursive. The subtle flaw is the sub-expression ac at fh. Recall that append is a linear time operation on singly linked lists. That is, if there are n list elements, then append takes time on, so at each recursive call we perform an on operation, and there will be n recursive calls, one for each element of the list. That's a total of n on work, which is on squared. Yeah, it's a good call out of me. I know that, but I don't know if everybody else knows that. But I think most people are really comfortable with map and filter at this point. Didn't used to be that way, but map and filter and reduce have all come to like most languages at this point. But people are, I just think, less comfortable with folds and reduces, and they will tend to just write a for loop, or they'll write their own recursive function, right, instead of using folds. Okay, so that makes sense because we're working with linked lists. Basically, we could make it that way. Okay. Yeah, but then it reverses it. Okay. That doesn't surprise me. Well, that's kind of cool. Like, if you didn't care about, if you were dealing with a large linked list and you did not care about order, then you could do list.rev map. That's cool to know that it exists. Yeah. I think that got a lot more popular in I think big data stuff made map filter reduce a lot more popular, right? Creating data pipelines. I knew what you're going for. I gotcha. Scala, the language that we love to hate, even though it's kind of a good language. Kind of. I don't know if it's a good language. It does a lot of good things. It has great features. I don't know if I'd call it a good language, I guess. Sorry, Scala. Just too much Java trauma, I guess. 4231 map in other languages. Yeah. Yeah, so map and tail recursion. I'm glad I read that part and I learned about list.rev map. That's good to know. Filter. Already know all about filter. Is there anything? Okay, we can create a tail recursive version of filter, and we still have the output being backwards. And again, okay, here the standard library makes a different choice than it did with map. It builds in the reversal to list.filter. Really interesting. So they filter it and then they do a reversal at the end. That's surprising. They literally do a ON reverse after the filter. Yeah. That's kind of surprising. Another really good thing to know though. Filter is tail recursive, but basically has an extra constant, right? Again, the idea of filter exists in many programming languages. Yeah, we don't care. Yeah, Scala has, I mean, technically it's multi-paradigm, but it has a lot of functional features. And, I mean, you can do things in Scala that you can't do even in OCaml, Haskell, and stuff too, if I remember right. It has like some notion of dependent types now, I think. I feel like I heard that, but I could be misremembering. I mean, there's really powerful things people are doing with Scala, for sure. Sometimes I have a hard time getting over syntax, but it all just depends on the payoff. Okay, and we go on to fold. Does Scala have a pipe operator? I actually don't know. Yeah, it's been a very long time since I've even bothered with it. I guess it was 5 years ago. Because I'll be at my current job for 5 years in a couple weeks here. Pretty crazy. I was interviewing for a Scala job just because I liked the company. Turns out that they weren't that great. I didn't like how they did the interview. I think they asked for a little bit too much on a take-home assignment than was warranted, but that's okay. ended up not being a good fit. And instead, I took a closure job instead of a Scala job. How about that? Map function gives us a way to individually transform each element of a list. The filter function gives us a way to individually decide whether to keep or throw away each element of a list, but both of those are really just looking at a single element at a time. What if we wanted to somehow combine all the elements of a list? That's what the fold function is for. Turns out that there are two versions of it, which we'll study in this section, but to start, let's look at a related function, not actually in the standard library, that we call combine. All right, so sure. He's going to write a sum function, and then he's going to say, but what if we could just instead abstract this to a combine? All right. I think we can skip this. We know where he's going, right? Recursively take the first and second elements or the init and go through there. Pretty typical reduce. Excuse me. Fold rights. The combine function is the idea. Hey, thanks for. I appreciate it. I'm glad you're enjoying it. We're having fun. I'm having fun. And I think it's going to help me just like solidify some of this stuff in my head. Like OCaml syntax. And it's a nice review of some things that I've known and, maybe forgot. Oh, it uses that same operator. It's funny to me. Very nice. The combine function is the idea underlying an actual OCaml library function. To get there, we need to make a couple of changes to the implementation we have so far. First, let's rename some of the arguments. We'll change op to f to emphasize that really we could pass in any function, not just a built-in operator like plus. And we'll change init to acc, which as usual stands for accumulator that yields. Let rec combine f acc equals function. If we have an empty list, we return the acc for a base case. Otherwise, we take the h and the tail, we apply the f to the h, and the result of applying combine to the tail. Okay. Second, let's make an admittedly less well-motivated change. We'll swap the implicit list argument to combine with the init argument. Okay, since I skipped over the combine part, I don't necessarily know what he's talking about. F list acc. What did we have before? Combine f acc. Oh, because the function keyword can just match on that last thing. I actually didn't know about that. I kind of forgot that that was a thing. So if you just want to match on one of your arguments, you can just put it last and still use the function keyword. That's cool. I kind of forgot about that. Are you talking about in Scala, Amit? Second, let's make an admittedly less well-motivated change. We'll swap the implicit list argument to combine with the init argument. Yeah. Combine f list acc match list with. Yeah, that's cool. I also kind of remember hearing about the way they do partials in Scala being like that. Basically, you can just put little holes. It's a little less convenient to code the function this way because we no longer get to take advantage of the function keyword nor of partial application in defining sum and concat, but there's no algorithmic change. What we now have is the actual implementation of the standard library function list.foldWrite. All we have to do is change the function name. Cool. Why is the function called foldWrite? The intuition is that the way it works is to fold in elements of the list from the right to the left. combining each new element using the operator. For example, fold right plus results in evaluation of the expression a plus b plus c plus 0. The parentheses associate from the rightmost sub-expression to the left. Yeah. So that's the difference between fold right and fold left. Neither fold right nor combine are tail recursive. After the recursive call returns, there is still work to be done in applying the function argument f or op. Let's go back to combine and rewrite it to be tail recursive. All that requires is to change the cons branch. Yeah. Now the function f is applied to the head element h and the accumulator ACK before the recursive call is made, thus ensuring there's no more work remaining to be done after the call returns. And guess what, guys? This is fold left. Okay. Pay close attention to the definition of ACK, the new accumulator in each of those versions. We procrastinate using the head element. It's one way of putting it. In the tail recursive version, we precrastinate. Nice. Very nice. Dad joke. By immediately folding h in with the old accumulator ACK. Then we fold that in with all the tail elements. Yep. The tail recursive version of combine works just fine for summation and concatenation, which we elide. But something possibly surprising happens with subtraction. Yep. So this is really great. I think this is a really nice explanation of the difference between fold right and fold left. I'm happy with this. It's a little verbose. We'll skip over a little bit of it. But if you're not like 100% on them, this is a nice little read. I actually like the way that he went through it step by step. And combine ter, surprisingly, is fold left. Let's review the differences between fold left and fold right. They combine list elements in opposite orders as indicated by their names. Function fold right combines from the right to the left, whereas fold left proceeds from the left to the right. Function fold left is tail recursive, whereas fold right is not. The types of the functions are different. Regarding that final point, it can be hard to remember what those types are. Luckily, we can always ask the top level. Yeah. It is kind of interesting that they chose to do it this way. It does make it a little bit confusing, but that's okay. I'm not going to read this. One way to remember it for OCaml is that in fold X, the accumulator argument goes to the X of the list argument. You could use list labels module if you want to use list functions with labeled arguments. Okay, that's good to know. List labels. Yeah. It's possible to write our own version of the fold functions that would label the arguments to the combining operator so we don't even have to remember their order. But those functions aren't as useful as they might seem. The problem is that the built-in plus operator doesn't have labeled arguments, so we can't pass it in as the combining operator to our labeled functions. We'd have to define our own labeled version of it. But now we have to remember that the ACK parameter to add will become the left-hand argument to plus. Yeah. Using fold to implement other functions. Let's see what we get to. Length, very nice. Little fold left. ACK plus 1, 0 LST. We have a reverse. Yep. Hey, Kyle, what's up, man? How have you been? Let map f list, list.fold right. Okay. And filter. Filter and map in terms of fold. Yep. Yeah, that was really nice. Yeah, I think it's a good call out. Like, basically the paragraph which I read while I was drinking. Yeah, I appreciate it, Kyle. This is nice to see you. Nice to see your username in chat. Basically about the readability of fold and understanding fold, but the thing about using fold is you don't have to worry that you did not specify your base case. Right? And you're not going to be in like an infinite recursion situation using fold, unless you're doing something wrong. So it's a good call out. It's partly why I sometimes will reach for a reduce enclosure instead of writing a recursive function. It just depends on how simple it is. It's usually what it comes down to for me. We've now seen 3 different ways for writing functions that manipulate lists: directly as a recursive function that pattern matches against the empty list and against cons, using fold functions, and using other library functions. Let's try using each of those ways to solve a problem so that we can appreciate them better. Considering writing a function list and bool is bool, such that list and returns whether all elements of the list are true, that is, it evaluates the same, sure. So list and rec, nice little pattern match. Recursion and pattern matching is just so nice. I mean, I get that the list, the like fold is fine, but it's just so pretty. It's so simple and pretty. Fold left is also nice. Yep. It's all good. Hey, Kinran. I'm doing pretty good. Thanks. Okay, so the worst case running time for all 3 functions is linear in the length of list, but the first function list, so the recursive one, has the advantage that it need not process the entire list. It will immediately return false the first time they discover a false element in the list. Yeah, that's another thing I didn't really call out. Like, if you want an early return, then you don't want fold or reduce, right? Yeah, I did actually. So I was able to, I don't have to do an overlay. So it was a trade-off. The trade-off was do an overlay or make our flakes impure. And I chose impurity over doing an overlay so that I didn't have to kind of like redo everything. Not that I'd have to redo everything. So I can show you the solution in a second that I figured out with the help of some people in another Discord. As for the third function, list and lib, according to the documentation of list for all, it returns, so like list and rec, it needs not process for every element. Yeah, okay, right. So obviously, like, you should just use list for all if this was literally what you were doing. But it's still nice. I still love the recursive and pattern matching. It just goes really nice together. Oh yeah, so let me show you real quick. So the main issue I had, quick Nix break from the I know. That's why I think it's even funnier to not do the overlay, is just for the meme. You're here for the Nix break. Nice. So quick Nix break from OCaml here. For OCaml, but from OCaml. So one of the issues we had, if we can sum this up quickly, is we had an issue that spices is being depended on by Riot, and then which is in another flake. It's a completely different repo, right? And then Mint T is dependent on Riot. Okay, so you kind of have this weird circular dependency, but it's not a true circular dependency. It's a circular dependency because of monorepo. That's really what it is. But from a flake perspective, how we were able to fix this is this actually works. It does make the flake impure, but it actually works is to say inputs mint t follows slash. And then you're good. And that way, the spices that goes into Riot is the spices in this flake that I'm building. So why does that matter, in case you're wondering? A couple reasons. Say you needed to make a change to spices here. I had another workaround for this before, which was worse. Like we can't have two different versions of spices coming in. That's content. That's like point number one, right? And then if you want to make a change to spices and you're making a change to mint tea and you want that to all work because leaves also depends on spices. Let's just say that, right? Okay. So you're testing out something in leaves. You made a change to mint tea and you made a change to spices. Like if we weren't using this flake spices, we could have package conflicts and it could be bad. My workaround before was to actually include mint tea, which is this actual thing, as an input. It inputted itself from GitHub. And that was a little bit silly, but it did work, surprisingly. But now input.mintt.follows / works, and I don't have to write an overlay. Yep, pretty exciting. Yeah, I was pretty happy with it. So thanks to the Alt F4 stream Discord, because those guys helped me out, and it was a classic Nix thing of one guy was like, I think this is gonna work, and if it does, let me know because this is gonna simplify a lot of my stuff. And I came back and another guy. And I said, "Oh, it works." He's like, "Oh, this is amazing, right?" And then another guy in the channel was like, "Now it's impure. I hate this," And he's like, "It's just classic Nix. It's like, oh, this is amazing, and this is terrible because it's now impure." Kind of classic functional programming, to be honest. But yeah, I got a kick out of that one. Okay, what time is it? We're at 3:05. I have to end in 25 minutes. I bet we can do this little map fold filter on trees. That shouldn't be too hard to get through. Functionals like map and fold are not restricted to lists. They make sense for nearly any kind of data collection. For example, recall this tree representation. Yeah, exactly. And I mean, I haven't quite hit the problem with impure in my workflow, but I'm sure you're right. Since you've done a lot more Nix than I have. I can imagine that it would cause problems at some point, but it's fine for now. Yeah, sure. So we can map on trees. Big surprise. You can map some trees. Mapping the value v at each node, and fold is a little bit harder. Sure. I don't think this is all that surprising. We can recursively fold through a tree. Yeah, totally. No, this is fun. Yeah, I do need to finish writing the rest of the flakes for it. I just haven't felt up to it yet. I've been doing the easy thing and just reading a book. And then filter on trees, pretty much what you would expect. I mean, that's the things, like if you understand how to do recursion on lists, you pretty much understand how to do a recursion on trees, assuming, you know, like we're talking about binary trees in this case. You know, you just do it. You just have a left and a right instead of a next. That's really all that it is. It's not too hard. Pipelining. Suppose we wanted to compute the sum of squares of the numbers from 0 up to n. How might we go about it? Of course, math being the best form of optimization, the most efficient way would be a closed form formula. Don't know what that means. N plus 1 to n plus 1. Divided by 6. Why is that divided by 6? But let's imagine you've forgotten that formula. Don't think I ever knew it. All right. Amit's about to come in. He's going to be pretty mad. Pretty mad about my lack of math knowledge. In an imperative language, you might use a for loop. The equivalent tail recursive code in OCaml would be let sum square and let rec loop I sum. If I is greater than n, then sum else loop I plus 1 sum plus I times I in loop 0, 0. Okay, sure. Another clearer way of producing the same result in OCaml uses higher order functions and the pipeline operator. Oh, so this is just about the pipeline operator? Okay. I thought that maybe he was talking about something else. Pipelining. It just sounded so cool, you know? But he's really just talking about pipeline operator. Okay. Yeah. The other alternatives you might consider are somewhat uglier. Very subjective, right? 3D Prima, thanks for the follow. I appreciate it. Hope you're doing well. The downside of all these compared to the original tail recursive version is that they are wasteful of space. Okay, well, this is more important. Linear instead of constant, and take a constant factor more time. So as is so often the case in programming. Okay, I think that's right. There's a trade-off between clarity and efficiency of code. Note that the inefficiency is not from the pipeline operator itself, but from having to construct all those unnecessary intermediate lists. So don't get the idea that pipelining is intrinsically bad. In fact, it can be quite useful. When we get to the chapter on modules, we'll use it quite often with some of the data structures we study there. Sure. Currying. The term curry does not refer to spices, in case you were wondering, but to a logician named Haskell Curry, one of a very small set of people with programming languages named after both their first and last names. How about it? Sometimes you will come across libraries that offer an uncurried version of a function, but you want a curried version of it to use in your own code, or vice versa. You want curry? Curry sounds really good right now. I've actually been wanting to get curry for a while, but it requires me either paying the DoorDash premium, right? Or calling the Indian restaurant and placing the order and then going to the restaurant and picking it up. Those are pretty hard. It's pretty hard. You know? I know, right? Pretty rough. No online ordering. I'm sure there's some Indian restaurant around here that has online ordering, but there's one that's literally like half a mile from my house. Get a little vindaloo. Vindaloo is very good. I even found some, now just close your ears if you're you know, from India, but I found some gluten-free naan bread because I can't have naan bread because it has wheat. And oh, it's very spicy. Yeah. Typically it's one of the spicier ones. I like it's a good kind of spice for me. I know it's totally a skill issue. It is literally a gut skill issue in that my gut for some reason hates it. It hates it. It's very sad. But anyway, I have some gluten-free naan bread that I found, and I've been meaning to get some curry to have with it. I haven't quite made myself do that yet, but we'll get there. Okay, so we know all about currying. I don't really care what he has to say about it. This chapter is one of the most important in the book. Then why did I go through it so quickly? Okay. Good. I mean, it is important. If you don't know map filter fold, map filter reduce, then I don't know where you've been. Have you even been programming in the last 10 years? Have you been using any languages in the last 10 years if you don't know map filter reduce at this point? That's so funny. LSM and PowerShell. PowerShell's got some wild features. Okay, so we got through chapter 4. We're on to chapter 4 exercises. I think we can do 1 or 2 of these. 3:15. I got some time. Hey, 3D. What do you say no to? That you haven't been programming in any languages in the last 10 years? 4.9 exercises. Solution to most exercises are available. He says this at the beginning of every exercise segment, which is fine. Twice, no arguments. Consider the following definitions. Double square, twice, quad, fourth. Use the top level to determine what the types of quad and fourth are. Explain how it can be that quad is not syntactically written as a function that takes an argument, and yet its type shows that it is in fact a function. I'm not even gonna bother doing that. Because it's a higher order function. But I mean, it's because of currying, sure. It's like, it's basically just, it's like a cheap compose, right? I mean, it's composing itself. You come from the desert of ancient C. Oh, okay, yeah. Unless you're in C. In that case, you have not been using map filter and reduce. Hey, how dare you? Wow. My daughter was being so rude just now. Just kidding. All right. Okay. Currying and other things. Yay. The camel will save you, 3D. The camel will save you. And if you don't know already, you know, you can get more gospel and salvation on Discord. Mystery operator 1, what does the following operator do? $fx equals fx. It seems like this just might be apply. Am I crazy? Yeah, don't think so. Yeah, if you have like questions, I'm happy to explain what I can. Exercise mystery operator 2. What does the following operator do? Let at fgx xgf. It changes the order of operation. OCaml 4ml. We did some SML recently too. Last fall, I guess. Not so recently. But it's not machine learning type of ML. I don't want to disappoint you. Exercise repeat. Generalize twice to a function repeat such that repeat fn x applies f to x a total of n times. Okay. Probably not going to do that. Exercise product. Use fold left to write a function product left that computes the product of a list of floats. And the product of the empty list is 1.0. Okay. Yeah. We can probably do this. All right. Let product left equals list dot fold left. So first we have our function. So we're going to use fun. XY, X times Y. And then product of empty list is 0. I mean, one dot, right? Why don't you like me? Oh, it's floats. My fault. And then it takes the actual list. So we can actually just leave it that. You don't actually have to name the list argument. We'll just let currying do its job. And we can say 1 dot, 2 dot, 3 dot. And those are just floats. Nice. And if we do product left empty, we should get 1 dot. Yay, we know how things work. Use fold right to write a function, product right. Yeah. So basically the exact same thing, except the accumulator is on the other side of the list. Is that right? List.fold right. Yeah. So in this case, we can't use the currying thing. We have to put our LST here. And we can still have the same function. And we have to do this. Should be right. Product, right. Actually, we'll just do this the way, be a little bit faster. Yay. Okay. Just thought I'd write those just so that I would like kind of cement the whole argument order thing, even though Emacs tells me what to do anyway. I'm going to stand up, even though it's time to go. We're still going to stand up. We're all going to stretch together. Come on, everybody. Got to stretch. There we go. Yeah. My hip flexor, it needed that. Okay, we're good. We're completely stretched out, completely limber. All the movement I need for the day. We're so good at this. All right. Terse product. How terse can you make your solutions to the product exercise? And you don't need the fun keyword. Yeah, we could just use, I believe we could change it to just use this. And thank you, bold something. Yeah, they were not clear instructions. That is true. I think I can do this. Can I? Might not be able to. I guess not. Comment not terminated. It thinks this is a comment. Do I need to put a space? Now does it think it's the right thing? Wrong place. Yay. Okay. So, of course, we didn't need to do the lambda. We can just pass the operator as its own function like this. I'm guessing the other hint is going to be currying. For fold left, your function definition does not need to take a list argument. Yeah. And I think that's actually a good place to stop because I need to go. So next time we'll finish up chapter 4 exercises and we'll move on to chapter 5. I can't say this is the fastest anyone could go through this book, but we're getting there. We're getting there. All right. Peace.